So hello, this is Heron again. Some titanium here. I wanted to try to alloy with copper, just to try it out. I mean, in theory it should form a eutectic alloy at about 22% titanium by weight. So, but first I will just cut a little bit from that ingot here and then cut a small slice of that and try to burn it just to see how it reacts. So I cut that stuff on a bandsaw and sliced a small piece off of that, and I will now try to burn that just to get a feel for the reaction, so that I kind of know what I got myself into here. So yeah, let's see how that burns and how easy it is to ignite, because I have no experience with titanium. Actually the first time I cut it, so yeah, we will see. Okay, let's try it. That should be hot enough to light it. There it goes, it seems to burn, but well, it doesn't seem to be that bad. I was thinking it's a little more violent. So yeah, it isn't that bad. See if you can get that started. Oh, it wasn't burning, kinda. Yeah, I think that was burning. So it's harder to, it's harder than you think, or that I thought, to even ignite it. So I think I'm on the safe side. I just wanted to try that out before I get myself into some hazard or whatever. That's quite interesting result. Didn't even burn completely. I mean, it burned on the surface, but yeah. Now you have this mixture of white and yellow, and yeah. Well, that's it. And tomorrow I will try to dissolve this piece in copper. I'm a little bit busy today, and the whole week had to do some repairs and finish some things at the on the house, and also I had to repair my 3D printer, and I'm also preparing a small room for electronic work, so kind of busy with that. So maybe I can get this experiment done tomorrow. So hello, here's Heron again, and I'm a little busy in the moment, so I just thought I would try a little kind of crazy experiment. I mean, it's not really crazy. Making a copper titanium bronze, and yeah, it can burn. I've made some experiment. I will show that. Maybe I cut that in now. So and it doesn't burn that violently, much calmer than I expected. So I'm quite comfortable trying it without any risk. I prepared 1 kilogram of stuff. It's 220 grams of titanium and the rest copper. That should form a eutectic alloy at about 22% by weight titanium. Got a new crucible out, so in case something burns, I have enough material so that the crucible will last even if stuff burns for 2 hours or something like that until it calms down, which I don't think happens, but just in case. So I will then get that burner set up to preheat the titanium. I will melt the copper, and then I will try to plunge that in with this hot dog thing. Hopefully that's enough, but I cannot go much thicker because of the small crucible and the thermal mass. I don't want to freeze the whole thing, so we'll see if that turns out usable. So that's the battle plan. Let's get started. So the copper is in, and I like to put one piece into the vent hole, let it stick out a little bit so that I have an indicator when it starts melting. The mold is just a sand mold, some test pieces and one of those force hammers, and just a piece of steel. I wanted to try to make an ingot that way. So copper starts melting, and I've straightened out all the stuff, and I just feed them in through the vent hole, like so. So here we go. Have some wooden burner here to heat up the titanium a little bit before I try to get it in there. Burn a little on the dish side, just to heat that up and get a little temperature in there. I mean, titanium has a low thermal mass anyway, and also a low thermal conductivity. So it kind of should work. I mean, it dissolves. Yeah, it dissolves. Nice. It dissolves. Okay, first part in. Yeah. Only 2 more to go, and they're much bigger. Oh. Let's see. So far those sausage tongs work quite well. I think I will use another torch to heat that up. Just use a butane slow boil. Where I can directly heat much more better. Okay, it's just like low, then glass. Okay. Next one. Camera a little bit to get the shape that we rip something. Yeah. Okay, next one. It's kind of getting more scary and scary because the titanium concentration is higher now, much higher, and it's getting higher and higher. But so far it seems that as soon as it is dissolved, it doesn't burn that much. It looks quite calm. I mean, there's glass forming like with aluminium bronze. They have the outside layer a little more than that, but yeah, we'll see. So far it looks good. harder, it's more thin. Nice wood. That was the last piece. Let's wait a little bit and cast it. Drop off. It's a test anyway. And here the fan from the old car radiator starts to squeak now. Anyway. Let's see. And we'll continue with it. Oh, it's frozen. No, no. Ah! I was worried that something like that would happen. With all that steering around. Let's get it up to heat and... well, we will see. So, yeah. Sorry about that. Just casted it and forgot to hit the button. So it seems to be castable. It forms a lot of jaws, but that's all. And yeah, it was kind of pain in whatever to get the stuff molten, or to get the titanium in there with such a small crucible, small thermal mass, without freezing the whole thing over. And yeah, it froze one time, but with a graphite crucible that shouldn't be a problem. So I'll now wait for that to cool down and we'll see what titanium bronze looks like. And by the way, kind of busy doing some repairs on the house. It's from 1889, so it needs a lot of TLC to stay in habitable conditions. So as soon as I'm finished with that, I will concentrate more here on the workshop and for the drill press to set up and some other things, and then hopefully I will get into more things than just doing a fun experiment by trying to alloying something. So let's wait for it to cool down. So it's cooled down and turned out to be quite brittle stuff. I mean, it filled the form, as you can see, and it has some kind of nice black scale to it. But other than that, yeah, it's silver, surprisingly. Thought it would be kind of bronze color or whatever, but I think that's the biggest surprise. Kind of like German silver or so. Has this silvery stuff to it, the silvery tinge. And it's harder than the hardened Knipex tong, so not usable yet, but I think I will remelt that and try to add some nickel. Maybe that will help to give it a little more toughness. Hopefully it will remain some of the hardness. Well, that's basically it. As I said, I'm kind of busy. I hope that ends next week somewhere, sometime, so that I can focus more on the workshop here and clean up and get some things set up, and yeah, we'll see. I will. Yeah, can see that quite coarse, silvery. I mean, it has this slightly goldish reddish tint to it, like silver, but it's not bronzy. And that's why I tried to hit it with the tongs. You can see it rubbed some steel in there, that's all. So yeah, maybe I can get that stabilized to a point where it's usable for maybe cutting tools or whatever, or just a silvery casting material with some for some artwork or whatever, like this one here. I mean, it would be nice to have this resistant black scale. It actually kind of looks like cast iron, especially with this with the coarse grain structure, and also ground easy, and it was sparking like iron. Not exactly like iron, more like steel. So the titanium seems to burn out if you grind it. So it's not spark free. Anyway, in this condition it's not really usable. So that's it for me for now, and see you next time. Thanks to Chippy for all the useful information and so on. I had to filter them a little bit because, for example, I cannot run electric induction furnace fuel rich. But other than that, it was quite helpful. So yeah, see you.